density times volume times gravity. We're gonna use the air density because it's the one it's making the force towards the balloon, so it go up. So that's the reason we're gonna use the air density. So we're gonna multiply it by the volume, that is 20, by gravity, that is 9.81. The result's gonna be 176.58 newtons. That's the buoyant force, the force that goes up. Okay, now the next formula we're gonna use is it's this one. We have already the buoyant force. We need to know how much extra charge or we can upload to the balloon. So we're gonna put buoyant force minus the weight, that is 94. You remember the weight go downwards, buoyant force go upwards. So we're gonna do this little operation, and it's gonna be 82.58. To that, we have already the force between this, the difference between these two. Once we have force, we can use this formula, that is force is equal to mass times gravity. We're gonna calculate mass, we already have gravity, and we already have force, so it's gonna be mass is the same as force over gravity. So mass, same of 82.58 over 9.81. Mass is equal to 8.41 kilograms. That's the extra mass we can upload to the balloon.
Next problem says that a balloon is filled with helium, has 21 meter radius, and the mass of the entire globe is 50 kilograms. What extra mass can be loaded?
So we're going to use the formula to calculate buoyant force, that is volume times density times gravity. We have gravity and we have density, but we don't have volume. That's where we're going to calculate volume. The formula to calculate volume of a sphere is 4/3 times P times radius cubic. It's going to be your volume of the just spheric disc. So it's going to be volume is equal to 4/3 times P times radius, is 21 cubic. The volume is going to be 12,348 P. That's your volume of this part. Now we have volume, we have density, and we have gravity, so we can calculate buoyant force. It's going to be buoyant force is equal to 12,348 P times density of the earth is 1.22 times gravity is 9.81. So the buoyant force is going to be 464,275.3 newtons. That's the buoyant force that makes the balloon go up. But they're not asking that, right? They're asking what extra mass can be loaded. So what we're gonna do, like we did in the last problem, we're gonna use the buoyant force, that is minus the weight, this mass and gravity, that is mass, that is 50 kilograms times 9.81. So the result is going to be 463,784.53. That's the result. Now we need to convert it, or with this formula we have the force. We're missing the mass, so we're gonna leave M alone. It's gonna be M, it's the same. Force over acceleration or gravity. So it's gonna be mass times 9.81. Mass is the same as over 9.81. The mass is gonna be 47,276.71 kilograms. And that's all.
The next problem, it says that through a tank terminal with a radius of 20 millimeters, water flows with a velocity of 3 meters per second. Does it take
The next problem says that through a tank terminal with radius of 20 millimeters, water flows with a velocity of 3 meters per second. What is the flow in liters per minute? And with the flow, how much does it take to fill a container of 20 liters? They're asking the flow rate. The flow rate formula is this one. But we don't have area, so we're going to calculate with radius. Then we're going to calculate in meters. So 20 millimeters is 0.02 meters. Once we have that, we can calculate flow rate with velocity and the area. This area is P times radius squared. Area is same of 1.25 and divided to minus 3. So we're gonna use Q is the same velocity times area. Flow rate is equal to velocity, that is 3 meters, times area that we just calculated 2 minutes ago. So flow rate is gonna be 3.76 times 10 elevated to minus 3 meters squared over seconds. That's our flow rate. But they want us to give them a liters, so we're gonna convert this in a convert chart. So we're gonna put 3.76 meters squared over seconds. We're gonna put here 1 liter is 0.001 meter squared, and we're gonna change seconds to minutes. So it's 60 seconds, 1 minute. So it's gonna be 225.6 liters per minute. So we have the flow rate. The only thing we're missing is the time. So we're gonna use, we can use like 225.6 liters per minute. So how many minutes gonna take to fill a 20 liter bowl? So we're gonna multiply this by this and divide it by 225.6. So the time is gonna be 0.08 minute. That in seconds, it's 5.3 seconds. So that's our time, and this is our flow rate. The next problem says that in a large tank filled with water, what is the rate in which water from a crack that is 5 meters below the surface of water spills? And the area of the crack they give us is 20 millimeters squared. What is the water flow of the crack? Well, the first thing they asking us there is the rate, velocity. So we have this formula that velocity is the same of root of 2 times gravity times height. So it's root of 2 times 9.81. We have height that is 5. So the velocity is 9.90 meters per second. That's the first result. And then they are asking us what is the water flow. Okay. Our formula to calculate water flow is equal to velocity times area. Area is 20 millimeters squared, but we need to meters. So we do this convert chart to convert millimeters to meters. Once we have the meters, we can proceed to do this equation. So Q is same, or flow rate is same as velocity, 9.90 times area, that is 2, 10 divided minus 5. So Q is going to be 1.98 10 elevated to 4 meters cubed over seconds. And that's the result. Ya, eso es todo.
Acá hablando en inglés,
Well, in the last problem that says that in the wall of a large water tank, there is a hole radius of 50 millimeters, located 4 meters below the water level. How fast does the water flows out through the hole, and what volume of water leaks through the hole in 5 minutes? Well, the first thing they ask us is to calculate velocity. The formula to calculate velocity is same of root of 2 times gravity times height. So velocity is same of 2 times 9.81 times 4 meters. Velocity same as 8.85 meters per second. We have our first result. Now we're missing the what volume of water leaks through the hole in 5 minutes. We have time. We have this formula. We have the time. We have we need to calculate the flow rate, and by last we need to calculate volume. Flow rate, we can calculate flow rate with this formula that is flow rate velocity times area. Velocity is same as 8.85, the velocity that we calculate here, times area that we're going to calculate with the radius. We need to convert it first to meters. That is 0.05 meters of radius. With this, we're going to calculate area, that is P times radius squared, and it's going to be 1/400p. That's the area. So velocity times area, that is 1/400p. It's going to be 0.06 meters cubic over second. Once we have flow rate, we can leave volume alone. So it's going to be volume. It's going to be flow rate times time. Okay, so flow rate is 0.06. And the minutes, we're going to convert that in seconds. That's going to be 300 seconds. So 0.06 times 300 is going to be 20.85 meters cubic. That's our final answer, and this is, yeah.
This is what?
This is me.
Thanks for watching. See you in the next video. Bye.